Good morning, everyone. I am Alban here from IB Tips and Chips. I am predicted IB 45 student, and today I am going to tell you all about IB mathematics. This is going to be quite the hefty video because there's a lot to cover in all technically 4 different subjects. So let's get right into it. So first of all, an overview of both AI versus AA mathematics. Starting with AA, actually, it's a lot more about abstract reasoning, algebraic manipulation, and exact answers, particularly in paper 1 and paper 3, where math is seen more abstractly as a subject than as a tool. The people who take this are oftentimes going into maths, physics, engineering, comp sci, or economics, whereas for AI, you use maths in a real-world context, use stats, data analysis, and modeling, and your GDC becomes a tool that you use for every single paper. It's more of a lens for understanding real-world situations, and it leads to careers such as medicine, psychology, and design, amongst others. First of all, the biggest tip I would like to share with you is to pick these classes based on what you enjoy but also what your university requires of you. A lot of universities require a high level for engineering programs or comp sci programs, so make sure you check you have a very general idea of what you need in order to get into the career you want. Now, looking at all 4 individually, you can see that for AA, the standard level curriculum offers core algebra, basic calculus, stats, introductory proofs, and only has 2 papers. Higher level has everything, as well as some more difficult topics, I would say. Induction proof, contradiction, complex numbers, and the Moivre's theorem, the Hopital, Maclaurin, just expanding a lot on calculus overall. And you also have paper 3, which is a lot about extended problem solving in unfamiliar situations. In AISL, on the other hand, you can see that there's a lot of real-world modeling, stats and probability, an emphasis on regression, chi-squared, which we don't really do in AA, and a lot of applied calculus. For both AI courses, you have a GDC for every single one of your papers. For AI-HL, first of all, there's also paper 3, as in AA-HL. It's a little bit different. This is about more of a real-world situation that you have to investigate during the exam. You have more differences in terms of content. For example, matrices, eigenvalues, graph theory, network algorithms, Markov chains, Voronoi diagrams, the Chinese postman, traveling salesman problems, all of these really interesting real-world situations that can be modeled, and I don't know, they have a completely different focus to AA, for example. In terms of difficulty, AA-HL is the most difficult one, and AI-HL, AA-SL are both on the same level of difficulty, with AI-SL being the easiest. Honestly, it all depends on what you enjoy the most and what you find the most comfortable. So don't just pick a subject because it's easier or because it's harder. Actually do realize what's going inside the content. Speaking of, we're going to talk about the syllabus. The syllabus is quite shared between the two in terms of structure. These are made out of 5 core topics for AA and AI, and they have key differences in what is being emphasized. So, as a rubric, not going too deep into it, you can see that we have 5 different topics: number and algebra, functions, geometry and trig, stats and probability, and calculus. Now, while these topics are in common for every single one of these classes, there are obvious preferences. For example, in AISL and in AI-HL, you have a lot more emphasis on functions because you're going to see them later on in real-world modeling problems a lot. And you have a big emphasis on stats and probability because you do things more related to regression, chi-squared, a lot of things that AA simply doesn't do. However, AA-HL and also SL, they put a strong emphasis on calculus and on the further integration and, for example, Maclaurin series type of things. It just depends what you would like to emphasize in your curriculum, what your choice will be. Now, going into the specifics for each topic, topics 1 and 2 would be numbers, algebra, and functions for both of the classes, and you would see sequences in series, logs and exponents, the binomial theorem, and financial maths for both types of math at both levels, but AAHL adds different types of proof and partial fractions, whereas AIHL adds pretty beefy topics like matrices, their operations, determinants, eigenvalues, eigenvectors, and complex numbers. In terms of functions, AA as a whole is more about abstraction and thinking of these functions as having specific properties rather than modeling anything really specific. You would see transformations, composite inverse functions, rational functions, remainder theorems, and analytical solving of inequalities, which sounds difficult, it's not too bad at all. AI Maths provides modeling and context, where you fit real-world data to different models, and you fit curves a lot using your GDC, and you interpret a lot of parameters inside of the context of your exams or your problems, which I find really cool actually. Topics 3 and 4. Geometry, stats, and probability. These are likely the easiest topics for AA and one of the harder topics for AI. They differ a lot. For example, in both SL courses, you get the basics, sine, cosine rules, 3D geometry, volume and surface area of common shapes. That's nothing bad at all. But AAHL goes in a completely different direction. You do vectors in 2D and 3D, the different operations between vectors, equations of lines and planes, more trig functions, and more identities. Whereas AIHL adds a lot of graph theory, spanning trees, Chinese postman and traveling salesman problems, which I mentioned earlier, and the Voronoi diagrams alongside matrix transformations. So they're two very distinct focuses, or foci, and honestly AI does really put a lot more emphasis inside of this topic than AA does, I believe. Oops. Then topic 4, stats and probability. Stats in Math AA is a little bit light. It's more about descriptive statistics like median, mean, mode, probability, normal distribution, and binomial distribution. There's also Pearson's product time coefficient, and regression in general. In AI, there's a lot of bivariate data. You have a lot of chi-square tests, Poisson distributions, and Markov chains, which is really the centerpiece for AI in this case. Is what really distinguishes it from AA as a whole. Just keep that in mind. And topic 5, calculus. The most beautiful topic in LFIB, if I'm being honest, but it's quite different in terms of the emphasis that each course provides on them. For AA, you have a lot of first principles, chain product and quotient rules, which I believe you also learn on AI. You have optimization, related rates, kinematics, and different aspects and techniques for integration. HL only expands on these by, for example, the L'Hopital's rule, Maclaurin series, implicit differentiation, further integration methods, so on and so forth. Also, Euler's method is a thing. That's kind of crazy. For AI, you use derivatives more as a way to express real-world situations. You can notice a trend here. As a way to represent rates of change. You also learn the standard rules, and you get to know a lot of optimization problems, more so than AA, I would say. And you get to understand integration as an accumulation of a quantity rather than just an operation. You also do rely a lot on your GC in order to solve problems related to optimization, or in this case also kinematics. HL adds further integration, also differential equations, and slope fields. The GDC is used freely throughout all of the papers, but there's less analytic depth and more emphasis on interpreting and using your data in a real-world context. Now, how do you study for math? I'm going to go over some general tips for both of these. You should always know the formula booklet. It's available in every single exam, and you shouldn't be wasting time trying to figure out where your equations are or what you have, what you don't. Be familiar with it so you can know when you can just look at the formula booklet or when you actually need to derive something on your own. Don't waste time in your exams, please. Always show you're working, because there are a lot of method marks. Even if you don't get the answer right, there's also ECF, error carry forward. The more you just explain your process, your thought process, and generally your mathematical ideas that come throughout, you can get method marks and reasoning marks in any given question. So just give it a try. If you don't know how it works, you can write down a couple formulas. You'll be fine. That's not true, actually. Just do try to solve the problem. Thirdly, you need to start early, especially for the higher level people and the higher level topics as a whole. You guys need to start early to let things sit in your brain. For example, complex numbers, which are honestly a big hassle early on, they will eventually sit in your brain, and by the time you get into exams, you already have a very good idea of what's going on with them. Fourth, you should master your GDC. AI uses it a lot more than AA math, but both of these need to be able to know precisely when they need it and how they need it. It's not a good situation to be in to not know how to operate your calculator in a paper 2, for example, where you actually really need the time. And fifth, you should start the exploration early. It's a little bit of a cliche thing to say, but this is one of the ideas that you can start very early and get a lot of feedback on really early. So, in the extent that's possible for you, try to find a topic that you're passionate about and try to develop it more and more so you can have at least one of them knocked off. Now, some specific strategies for each type of math. For AA, a lot of errors are algebraic because you can't really rely on your calculator for a lot of things. You have to manipulate and derive a lot of things. So fix your algebra hopefully within the first year, and then spend the second year kind of consolidating the little errors that you may encounter here and there. Paper 1 has a lot of exact answers, so you should practice how to give them in terms of, for example, radians, surds, fractions, and you should know your trig values really well. So, HL also has a lot of proofs. You should practice induction proofs specifically because you have a really fixed structure and you can get marks by simply just writing a bunch of sentences. Maybe irresponsible for me to say that, but yeah, do learn the sentences. There's 3 free points. Also, complex numbers and complex vectors. No, complex numbers and vectors, what am I saying? They're topics to put a lot of consistent effort in. As I mentioned before, you should start early and let them sit in your brain. Abstract problems need a lot of recognition of concepts and not for you just to memorize the formulas. You should learn to link all of the syllabus together. Then for paper 3, you should just practice past papers and practice difficult math questions because you should learn how to stay calm in this unfamiliar territory that paper 3 is going to put you in. And you should be able to quickly get on your feet and apply the known strategies you have in order to solve any unknown problems. For AI, you should always be mindful of how you format your answers. For example, 2.3 doesn't mean anything, but the population grows by 2,300 units per year. It earns marks. You need to be able to interpret and analyze the data that you have in a meaningful manner. Stats is the core, as I mentioned before. You should not skim any of these. You should have them really ready and in your pocket for the exam. You should be 100% sure of how to use your GDC because you use it for all 3 papers and it's required for all 3 papers. You should know every single statistics function and also how to do a lot of cool calculus inside of your calculator. For HL, similarly to how AA-HL has their complex numbers, graph theory and matrices, Markov chains, they're unfamiliar to most students, so you should let it sit in your brain for a little bit so you can be more competent in exams. You should also be able to quickly spot connections between different areas of maths. That goes for both of them actually. You should be able to connect, for example, matrices and probability in order to solve problems much quicker. For paper 3, you should learn how to communicate your math as much as you know how to do math. You should show your reasoning very well so that the examiners can know whether to give you marks or not. So, the external assessment. Now getting to the chunky part of it. For AA, you have 2 papers for SL, 3 for HL. Paper 1 is common for both, but there's a clear discrepancy in time and marks. Both of these have a section A, which is relatively short response. You'll find a maximum of like 9 marks per question here. Whereas section B is more extended response, and each full question takes like from 13 to 21 points each. Both of these do not allow any GDC, any calculator. and you should be able to give all your answers exactly and really refine your algebraic skills for this one. For paper 2, similar discrepancy in time and marks for SL and HL, and also in weighting. Oh my god, I just saw it. You also have a section A and section B, similar formats, but in this case you do have a GDC, and this is more focused on learning how to use a GDC. You have a lot of probability, you have a lot of cool geometry that you need to do. Anything that requires your GDC, honestly, is going to come up more often than not in paper 2. And in paper 3 for HL, it's one of the harder papers. Thankfully, it's not weighed as much. It's only 55 marks in an hour 15 minutes. And they're 2 questions only. They're really big questions, and they're meant to be unfamiliar to the students that are writing it. So you should always be quick on your feet. Oh my god, there's a lot of green in this. For AI, the papers are similar, quite similar actually, to AA in terms of structure. You can see the same discrepancy in time, marks, and weighings here. But there's a lot of interpreting answers in context, and paper 2 is a lot about extended response. So this would be like a section A, this would be like a section B. And for paper 3, in HL, you have a similarly structured paper 3, but it is a real-world investigation in which you need to communicate your answers very clearly. Fourth, the Math IA. This is a topic that really screwed up a lot of people, but hopefully with these tips you'll be able to do better. First of all, what actually is it? It's, firstly, what needs to be addressed, it's 20% of your final grade, 20 marks total. It should be 12 to 20 pages, double-spaced, and it has 5 assessment criteria. Now, with that out of the way, what actually is it? It should be an investigation that comes from you of an area of mathematics that genuinely interests you. It should be your own research question, methodology, and conclusions, and it should be also your writing. Since it's marked by your teacher and externally moderated by the IB, you should also take advantage of that and be able to receive feedback from your teacher quite often. It cannot be the same work or similar in a lot of capacities to your extended essay. One thing that you should not do is to copy it like a textbook proof. You should be able to explain it such that anybody that doesn't know the topic can get into it and understand the topic by the end. It should not be a Wikipedia article reformatted, or a standard exercise, or any report on topic that doesn't have actual investigation and development from your part. Of course, lastly, it should be all yours. There are 5 assessment criteria in here. First of all, the presentation, if it's well organized, if everything's placed correctly, if your equations are centered. Then, mathematical communication. How well are you able to make the examiner or the reader follow through with your steps or what you want to say? Also, criterion C, personal engagement. This one is a little bit difficult to explain. It's awarded holistically in IB, and it just measures if the work feels genuinely yours. If you have curiosity, if you've cared for the IA in a meaningful way that is personal to you. That's kind of redundant, wasn't it? So, criterion D, reflection. You should be able to consider the significance, strengths, and limitations of your IA and be able to give a forward-looking vision on how this investigation could be improved in the future. And then criterion E, which has the most marks, is the use of mathematics. Having correct notation, correct algebraic steps, in general, being orderly and, being within kind of the guidelines or the etiquette of mathematics. It's also a little bit more abstract, but I'm sure that your teachers can help a lot with that. And if not, you can shoot us a text and we can review it for you. So, criterion E carries the most marks for every single one of these. So you should choose a topic in which you can use a lot of mathematics and you don't only describe in text. You should use at least the level of the content that you see in your math class. For example, in AAHL, you're supposed to use the AAHL math as a baseline. Here you have some sample topic ideas, and what I want to get into the most is a timeline. Now, it's kind of difficult to start doing anything in the first half of year 1, so you just need to brainstorm and explore the ideas that could have potential, talk to your teacher, and receive feedback from them. Then, year 1, in the second half, you should be able to finalize the research question and check the level of maths that you have. Then, in early year 2, you should investigate and collect all the data and develop the maths necessary in order to do the actual IA. In mid-year 2, I actually would recommend doing this slightly earlier. You should be able to write the draft and receive the feedback from your teacher. In late year 2, you should be able to revise and submit your final version. Please do it before exam season because there's no way to submit it to IB after that. Here's a final comparison of both of these. You can pause in order to look at a summary of all that I've said so far. And you should remember these 5 things. You should choose based on your career and prospects, but also based on what you enjoy the most, depending on whether you enjoyed, for example, algebra or statistics more in school. Your GDC is a tool. It's not a crutch that you can rely on. You cannot simply just state by GDC in your exams and get full marks. You should understand what it's doing and be able to clearly reason it within exams. The exploration is 20% of your grade. It should be done at the very least competently, because otherwise it will pull your grade down, or it could also pull your grade up, depending how well you do it. And both courses develop the same thing, a rigorous way of thinking. One of them is more application oriented and the other one is abstractly oriented. This skill will be amazingly useful regardless of whatever you study next. This is one last reference card and summary of all that we've talked about so far. And if you have any more doubts about the courses or the IAs or anything regarding that, be sure to shoot us a text in the contact provided in our YouTube link. And yeah, thank you very much for listening, and I hope you guys have a great IBD. Peace.